Hello, my name is Jeff, and my colleagues and I spend a fair amount of time in the local high school AP Computer Science class where DrJava is one of the common development environments for the students. Our observation, however, is that the debugger has not been taught well, and yet it's a very common tool in industry. So our hope here is to give people a demonstration of the debugger in the DrJava environment by showing them three basic things today. How can I stop execution on a program? How can I check values of my local objects or variables? And how can I control the flow of the program? So as we get started today, first of all, I want to point out we're using some very simple code created by a colleague of mine, Dave, who did a wonderful job pulling this together for us. That code has been posted to a public GitHub repository that you see located here at the bottom. If you wish to follow along, please go out to that GitHub, pull down the examples out of that, and we'll be doing today's exercise in the Java or the debugger.java file. So before we get started, there's a couple things you need to check. First of all, it's always helpful to make sure that you have the right level of DrJava. I have noticed that some of the older versions, particularly from 2014, don't seem to have debugger support, or at least have a conflict with the Java level we're using here. So please go out to the DrJava website, pull the latest stable, which for us you see is the September 13th build of 2016. The next thing you need to know, or sort of a prereq for debuggers, is you have to go down to the compiler level and you must run a Java development kit, or a JDK as it's called. You'll see here we're running the JDK 8, which is the most recent level of Java as of the time of this, this video. So please pull down and load the JDK 8 and make sure you verify that that is in your environment, that you're running DrJava. So then the next step becomes, how does one actually get into debug mode? We're used to normally running a program. This program in particular, if we run it, we'll see that we get output that says basically hello world. It runs through a set of index and it prints a final string. If we look at the source code, we see that there's a main class or a main routine inside of our debugger class that gets control. There you see on line 28, you see the print line, you see the for loop that generated each of the current index statements by calling off to this concat and print routine, and then you see the final string contents. Oh, by the way, that concat and print routine is down here below, so everything is very nicely self-contained. One of the other things I should point out that is also very helpful is having line numbers when doing debug. And so you can see the line numbers on the left. If you want to find out how to enable line numbers, simply go to Edit, Preferences, go to the Display Options, and this Show All Line Numbers box needs to be checked and applied to be able to get those line numbers on your screen for debugging. Okay, so activating the debugger. Normally, like you said, we just do run. Everything runs to the end. We see our results. We would either like them or not like them, and likely to do debug, we would use a system.out.println statement to collect whatever information we want. But for getting started and showing an example, to use debugger, you have to go up here, of course, to the debugger pull down and go into debug mode. When that happens, you get a new window that pops up, or a new frame inside of your current window. You can make it bigger, you can detach it. For the sake of this demo, we'll leave it there. But let's go back and just take a quick look at how we can tell if debugger mode is on or not if that window's been put away. Basically, this little black diamond here indicates that we're in debugger mode. It's the safest way to know. And typically a way that you'll know that it's not been turned on is you can start setting breakpoints, but you don't seem to be hitting them. So if you find yourself missing breakpoints or not hitting them, make sure you go up and check to see that you're in debugger mode. Okay, for our first example, let's use this basic concept of how do we stop execution somewhere in our program. We do that using something called a breakpoint. To set a breakpoint, go up to this space between the line number and your program, right-click on it, and you will see at the bottom this toggle breakpoint option. Click on that. You'll note then that that line becomes red, and you will see down here that you will get a new tab in the bottom frame called breakpoints that shows you where the breakpoints are listed. So let's set that breakpoint. Let's also set one inside of our concatenate and print routine, as we determined that will be called multiple times. Let's go ahead, set one in there on line 41, toggle that breakpoint, and now we have two breakpoints listed down below, and they're highlighted in red. So now let's look and see what happens when we run. If we run, we suddenly get notification in our interactions window down here that we've hit a breakpoint, and we now see that line 28 is highlighted in sort of this teal color. Exactly where we expected, line 28. But let's now go down to this window that appeared when we turned into debugger mode. You see two tabs here, stacks and threads. Stack tends to be a very important window to look at, especially as your programs get bigger. If we go to the bottom of the stack, this is all the routines, and it includes mostly Java environment routines that we don't provide as a part of our or routines that are provided to the framework, but we didn't actually write. And we see that our first breakpoint then is at the top of this method main. And if we go over to this window on the right-hand side, resume is the first control we're going to learn. Resume is a way to give control back to the program and say run until either you finish or you get another breakpoint. So in our case, if we hit resume, the breakpoint we were on in 28 goes red because it's gone, or we passed it but still there, and we've now hit our breakpoint in 41. This is also notable down in our stack window where we see that concat and print, our routine that we're in, is at the top of the stack, and we've now sort of pushed down the debugger.main routine where we had our last breakpoint, because that is the flow of the code inside of our environment. So sometimes you may want to set a breakpoint in a routine because you wonder how you got there. There may be multiple entry points, and using this stack frame will help you do that. And you can simply then control how many times you hit it by simply clicking on the resume, letting it run, and continue. So in this case, we can see that we're continuing to hit line 41. We see that we are indeed getting the text of the current index is, etc. And that is how we control basic flow using breakpoints and resume. Now, let's change slightly. Say we want a little bit more control. Well, I'm going to adjust breakpoints. But before I do that, there are two ways I could remove all the breakpoints. One is to remove them manually. Let's just simply go up to this breakpoint on 28, right-click on it. If we simply toggle, that breakpoint goes away. It's visible down here that it's also gone away in our breakpoint tab. But the other way to remove all breakpoints is simply to just click on remove all, and we can see that all breakpoints now have been removed. So for this next exercise, let's add a breakpoint here inside of our inner loop back in the main routine. We have this loop. Let's set a breakpoint right here. Again, we'll right-click, we'll click on toggle breakpoint, and we'll simply restart our program by doing a run. When we do that, breakpoint went red while things were resetting because it was only there, and of course we stop at the breakpoint that we've selected. Now let's explore three of these other buttons: step into, step over, and step out. Well, the most obvious two here are step into and step over. If I step over this function, I won't actually go into the function. It will execute all of it, come back, and give me control down on this line 33. So let's assume that's what I want to do. I don't care what's going on in concat and print. I simply want to see that I come back. So let's step over. Let's try that. Sure enough, we get control back on 33. Let's continue our step overs. We're back at the top of the loop. Now we're back at our breakpoint. That's how step over works. Now let's try step into and see the different result that we have. If we step into, one might theorize this is a way to get control inside of or take the next step that is inside of our concat and print routine. Let's try that. Step into. Ah, look. There's step into. Step into basically takes us into the routine. Let's try a step into on this line 41. If we step into the system.out.print line, ooh, it came back. It acted like a step over. Well, that makes sense because, quite honestly, we don't have the routine and we don't have the code for the system.out.print line. So step into will actually work like a step over and give you control back at the next line if that is not one of your routines. So that is how step into works. And let's then explore the step out, which basically takes you to the return from where you came, and then gives you control back at the place where you came from. We see on the concat and print, and I suspect if we do this step into, we actually show that we weren't going into the concat and print, we were coming out, because it takes us now to this test and the next statement after the call here. So basically, step into allows you to take one step into a function if you have the source for that. Step over allows you to step over the function, and step out allows you to run all the way back from your current function to where you begin. Okay, now let's do the final example. Again, let's go down to our breakpoints. Let's remove all and explore the idea as to how I might get information about what's occurring in my program. Let's look in particular at this loop from line 30 to line 34. Let's assume there's something going on there that I don't understand, and let's, like we've done before, let's just set a breakpoint at the concatenated print, line 32, rerun our program, and get there. Now, as we know, there are multiple things that are sort of valid here as far as objects. I is an interesting object, string is an interesting object, and test is an interesting object. Wouldn't it be great if we could look at those objects and figure out where they're at? Well, let me show you. If you look over here real carefully in our debug frame, there's a pair of arrows that allow you to open and close something that's not quite showing here. If we open that and expand it a little bit, because we've been looking at our stack and we're going to ignore it for the minute, there's this concept of watches. Watches are a way to look at objects, classes, and your data, for lack of a better example. So to look at, say, the item I would go over here, I would right-click on the name field, and I would type in the name. Now, my apologies here. You can't see that I have entered the I. It's a visual anomaly in DrJava. But if I hit enter, it will be entered, and we'll see that I has a value of 0, and it tells us its type as well. Let's also look at string, str, or stir, whatever you want to call it. Not found yet, because basically it's not defined. And let's also look at test, which is where our running set of values are defined. We see that test is defined as Java lang string, which is what we'd expect from the declaration in line 26. So now let's do a step over our concat, and let's look at what has happened. So we called into concat and print, returned a value. Now stir has a value of 0, comma. We see that it is a string, and it looks like if our code is working correctly, it will then take that value and assign it to test. So let's do another step over. And sure enough, we're now back at the top of the loop. Test has 0. Stir is now not found because we've come back to the declaration. Stir has become undefined, and we're back at the top of the loop. Let's go ahead, step over, Now let's look at stir. Stir now has a value of 1 comma. Test still is 0 comma. And according to what we expect to happen, if we step one more time, stir will have a value of whatever test will have its previous value, but will be concatenated with the new stir value, which of course we see 1 and 0. And we're back now control at the top of the loop. So if we continue stepping over, we will see that stir continues to get the index number and a comma, and then that gets appended to the test value to the point where this allows us to walk through our loop seeing the values change all the way to the end where we get to 9, we're at 6, 7, now 8. Okay, now let's assume this last time that we want to watch how 9 gets assigned, because we know 9 is the last sort of tricky one. So let's use our step into. Let's go into the concatenate and print, and we see that, look, I still has a value, but stir and test don't. That's interesting. Well, no, not really, because stir and test have lost, we'll say, the word context. Maybe that's a concept that's familiar with you, but basically those are no longer valid variables or value objects in this routine. And so if we step over a couple times, we know that we want to maybe look at this myString value instead. So let's add it in, myString, hit enter. There we go. Now we see myString has that I value. Now let's just sort of step into, we'd expect we better look at max. We'll type in max. Max is 10. We'll expand that so we can see it a little bit more. Max is 10, I is 9. If I is less than max minus 9, we expect to do append a comma, but let's see where it goes. No, it wasn't less than max minus 1, so we simply return the string, and when we step from here, we will get back to the point where stir has not yet been assigned, but stir now is just 9, not 9 comma as it was with the previous ones. And if we step again, we see that 9 comma has been assigned to test, and that's what we expect. And so if we continue and resume running, we will complete and be done. So hopefully this demo helps you understand how to use the debugger, how to stop execution with breakpoints, how to control your execution using the resume, step into, step over, step out functions, and how then to use watches to see what values are. This should enable greater efficiencies in debugging your programs, especially as they become more complex. So go out, pull the source code from this Git tree at the bottom, play around yourself, and start to use this with your programs. And keep your eyes open for more videos. As we find some more advanced concepts, we'll make sure we share them with you. Thanks a lot, and happy debugging.